Good morning and welcome to Algorithm Cafe, where I'm sitting in the Santa Cafe, just having been served my lovely black coffee by Prabhu with a what looks like a blueberry muffin here. Yep, quite warm. Listening to these two at these three at 7:05 in the morning, poking fun at each other. It's good. Okay, last night we had our first Algorithm Cafe, and here's the feedback. So this is what we did. We did three simple exercises that turned out to be not quite as simple as we thought, but we got through them. And first of all, I'm going to do this one, which is adding up all of the odd numbers between between 1 and 99. And I'm going to type it straight into EZ pseudocode using the brilliant EZ pseudocode hack by Dave Mulkey. Thank you very much. And here we go. So I am going to, for this, I'm going to need a loop because I'm going to have to repeat things 100 times from 1 to 99 times from 1 to 99. I know how many times exactly that's going to execute. It doesn't depend on any other conditions at all, that loop. It's just the number of times that it executes. So I'm going to use a count loop. And what a count loop does, as we discovered last night, is it allows you to go through a fixed number of times and increments the variable by 1 each time. So the syntax for a count loop is loop and then the name of a variable. I'm going to call this t from 1 to 99. And of course I need an end loop as well. There we go. So in the middle, I'm going to need to add these numbers together. So I'm going to need to say something. I'll make a variable. My variable is called total. Total equals total plus t. So that will add together excuse me, all of the numbers between 1 and 99. However, I've said here that total should be increased by t each time through the loop. So I need to give it an initial value. So I'm going to say total equals 0. Now I notice that I've made a terrible mistake here. Variable names should be in capital. So that's the first thing you can know about pseudocode, is that all variable names are in capital and everything else is in smaller, lowercase. So there we go. So that will add together all of the numbers between 1 and 99, and it'll increase the variable total by whatever that number is each time around. So I'm just going to print out the answer in the end. So to print out the answer, output the variable. Now if I run that in the box at the right, I get 4950, which is the correct answer. Now, I just have to make one small modification here, because this all works. The only thing I have to do is only count the numbers which are, if you look back, the numbers which are odd. So I'm going to need to check first of all, before I increase this variable total, before I add t onto it, I need to check whether the number is odd or not. And the way I can do that is dividing and looking at the remainder. Now, if I want the divisor of two numbers, if I want to know the number of times that 2 divides into 5, I would say 2 div, div, 5. That would give me 2. If I want to know what the remainder is, I would say 2 mod, mod, 5, and that would give me 1. So let's use that, because if I divide something by 2 and the remainder is 0, then I know it's even. If it's not 0, I know it's odd. So I can say if t mod mod 2 equals, I'm going to say not equals 0. In that case, I know it's odd, so I'm going to add it in there. And remember, you always have to have an end if for every if. So if t divided by 2 is, the remainder of t divided by 2 is not equal to 0, then I add that number on. Okay, let's give it a go. Alright, and as usually happens, or as frequently happens, there's some sort of an error here. So if has an end if, I'm just checking, right, in EZ pseudocode, you do need a space on either side of the if for it to be able to parse it properly. So I'm just going to, there's either side of the equal, sorry. So I'm just going to check whether it's that. Alright, see if we can do something else. Maybe a space in here. Box at the right. Okay, And what if I add in the keyword not instead? That's probably what it's looking for. Okay, so I think I get the feeling there's something wrong with this line here. Now, it's not necessarily wrong with pseudocode, it's just this tool. So what I'm going to do is I'm going to reverse that. So I'm going to say if I'm going to say greater than 0. So if mod 2 is greater than 0, if t mod 2 is greater than 0, that's probably going to be simpler for it to understand. Alright, look, let me work through this. If t mod 2 greater than 0, in other words, if it's odd, there's definitely something wrong with that bit. Now, right now is where I would look at my pseudocode examples. So I'm going to jump into David Mulkey's tool here, where he's got see if he's got a mod example. Calculations. He's got a mod. No, he hasn't. Yeah. What about column factors? If A mod C equals 0, so he seems to have that. And now has he got a not in there? I remember reading something weird about nots, as in don't use nots or something like that. Here we go. One warning, the keyword not should never be used as part of a variable name. Okay, that's fine. That's alright. So he does actually want you to use exclamation mark. Or sorry, the word not, N-O-T. Now curiously, I wonder what would happen. I'm just going to keep on with my original example. If t mod 2, I'm going to say not equals 0. That's the one that didn't work. Now he seemed to have put not in capital letters there, so I'm going to try not in capital letters. Whoops. Run it in the box on the right. No. Not equal if t mod 2 not equals 0, total equal to, variable name, t, lowercase, of course. Nope, still doesn't work. T mod 2 not equal to 0, total. Alright, I might just give up with this and chalk it down to experience. Total equals 0. Loop t from 1 to 99 if t mod 2 is not equal to 0. You need a then on the end of the if line. Nope. Okay. Alright, t mod 2 not equal to 0. What about a then on the next line? That be okay? No. Total equals total plus t. And if and loop, I put total. It's got to be something with these two lines. Look, if I comment that, and I comment that, and then I run it, it gives me the correct answer. So if t mod 2 not equals 0, then if I try and say it another way in case there's a problem with the tool. Mod is greater than 0, then what's wrong with you? Okay, I need to have I need to have a look at another example of an if. So I'm going to look at an if then. So he starts with if, then he's got an expression, and then end if, which is exactly what I have. There it is with an equals. Does he have any with not equals? No, no examples of that. Password logic, let's have a look at that. Name equals Bozo, name equals Einstein. There's an or in there. Money decisions, if it's that, it's that. If t mod 2, what if I put this inside brackets? T mod 2, run that. No. Okay, gonna pause this and have a think about it. Okay, just abandon the cafe and come upstairs to my classroom, open my laptop, and it's staring me right in the face. Ridiculous. Okay, there you go. I just told you before that variable names have to be in capital letters and everything else is in lowercase, didn't I? Well, look at this. This is not a variable name. I put this in capital letters. My bad. So there we go. I don't think I even need that. And I think I can go back to the original not equal to. So fingers crossed. This is going to be embarrassing if this doesn't run now. If t mod 2, if t, the remainder of t divided by 2 is not equal to 0, then increase total by t, and let's run it. Okay. Come on, try that. Something to do with that not equal to, isn't it? So I'm just going to say greater than. There you go. Okay, so it's that not equal. The tool doesn't like that not equal to. However, this is fine. So what I'm saying here is I've just modified this syntax slightly so it runs in the tool. If t mod 2, if the remainder of t divided by 2 is greater than 0, I can say greater than 0 because you're never going to get a negative remainder after a division, then total equal total plus t. Normally, what I would write is if t mod 2, there's a special symbol in pseudocode for not equal to, the mathematical symbol, the equal to, equal sign with a line through it. But I'm just going to try that, and that seems to work. Okay, so in easy pseudocode, you write not equal to. In the real pseudocode, when you're writing it in an exam, you'd write an equals with a diagonal line starting from the top right and going down to the bottom left. Okay, or that would be understood just as easily. There we go, that took a little bit longer than expected, and that was the starter. Brilliant. Let's move on to the next one.